Namaste, welcome back to Pragna channel. You are watching AWS Cloud projects for beginner to expert levels, and so far we have done 10 projects as a machine learning engineer, but we didn't do much. We just trained those models, deployed them, tested them. That's it. And we are provided with all the required scripts. I am not a machine learning engineer, so you can actually download these projects from the GitHub links that are mentioned in the video. You can get them, but if you are looking for how to integrate that into AWS environment and how to train them, deploy them, and test them and integrate with other AWS services, then go ahead and watch these. But if you are looking for something that explains these algorithms and models, no, then this is not it. All right. You can go ahead and download the code, and maybe there are other videos who explains that. Maybe if you know such videos, then do recommend me because I am planning to prepare as well. So I think in the last video or one of the video, I requested you guys to share such videos or books or anything that teaches machine learning concepts, you know, for even dummies like me. Please do recommend them, because these are some concepts, not none of the concepts I don't think I will understand it just by reading it here. So if you guys can recommend me those, I will have to at least read 10-15 times before I can make some sense out of them. Okay, I really appreciate that if you do it. So do share me all those if you know, of course. Anyways, this project is going to be about TensorFlow and computer vision. So let's go and pick the project. And this is project number 89, by the way. So let's go and pick it up. I think from now onwards, we are going to pick projects that are focused on different services. For example, as we already know that, what is that service? Forecast is one of the service on AWS which focuses on time series forecasting, right? Or predictions, right? So something like that. I think from now onwards, all the tools that we are going to use are machine learning services, but focused on one algorithm. So SageMaker, you can run pretty much any algorithm, machine learning algorithm that's out there, but some services are created so that you don't have to know anything. You just put your data, etc., and it will give. For example, if you want to convert from videos to text, etc., and all. So let's see. In this looks like we are going to learn about TensorFlow. So let's see. Hey, we have a peculiar issue. Can you help us? Hello there. What is your issue? Let's discuss. The city's farming company noticed animals entering their research vegetable garden. While frogs are welcome, cats and dogs are not. We would like a solution to detect if the visitor is a cat, dog, or frog. This is an interesting case. How do they monitor their garden? They use a motion sensing camera to take images of the little visitors. I'm interested in using deep learning to solve this problem. Awesome. This sounds like a problem that can be solved using computer vision. Do you have a specific deep learning framework in mind? Yes, we want to use the TensorFlow framework. We want to specifically use TensorFlow 2. Is it fully supported on AWS? Absolutely. AWS supports broad support for TensorFlow. You can develop and serve your own models across computer vision, natural language processing, speech translation, and more. You can get started with TensorFlow on AWS using Amazon SageMaker, a fully managed machine learning service that helps you build, train, and deploy TensorFlow models at scale. In addition, AWS Deep Learning containers are available as Docker images in ECR. Each Docker image is built for training or inference on a specific deep learning framework and Python version, both with CPU or GPU support. That is really encouraging. Are datasets available to train the model? Yes. You can use the CIFAR10 dataset as a sample to train and test your model. The CIFAR10 dataset consists of 60,032 by 32 color images in 10 classes with 6,000 images per class. I don't know what. what they just said. Can we use the same approach to solve other similar issues? Yes, you can, depending on the data and use case. This request is urgent. Can you build a sample approach to solving our image classification problem? Let's accept it. Fantastic, let's do it. We are going to learn how to open SageMaker Studio and import sample lab code, which we already know. Run practice notebook to train and deploy the ML model, which we already know. Run the DIY notebook to train. Okay, we already know all these things, but I think we will learn about TensorFlow. Let's go to the video concepts, and we have TensorFlow added to this one. The remaining ones are, I think, even computer vision. So I highly recommend you to watch these videos. Even I am watching these videos. Don't forget about that. You can watch these videos on the playlist that will pop here. Click on that and search with these titles in that playlist. Once you finish watching those videos, come back and watch the rest of the project. This solution uses SageMaker with TensorFlow to deploy a deep learning architecture that uses computer vision to label animal images. Developers can use the TensorFlow on AWS framework to quickly get started with deep learning in the cloud, particularly in the areas of computer vision, natural language processing, and speech translation. Unlike traditional machine learning, deep learning attempts to simulate the way our brains learn and process information by creating artificial neural networks that can extract complicated concepts and relationships from data. I think, is this the one they said it's a combination of computer science, neuroscience, and psychology? SageMaker uses AWS deep learning containers, a set of Docker images for training and serving models in TensorFlow. Deep learning containers are available in ECR. The Jupyter Notebook Python scripts image dataset required to train the model are stored in S3 bucket and can be accessed from within SageMaker Studio by using AWS command line interface. You can use SageMaker Studio to interact with the TensorFlow libraries to train and validate the ML model. Deploying a SageMaker endpoint starts a Docker container optimized for TensorFlow serving, which allows predictions to be made in real time. Changing or deleting model artifacts or inference code might lead to unpredictable results. After changes, you should create a new endpoint and delete the old model artifacts. Let's see what we will be doing. So the practice lab goals will import and review the CFR10 dataset. Then we'll train a convolutional neural network model using a TensorFlow framework. Then we'll deploy the trained model to a real-time endpoint by using SageMaker. Then we will review the model accuracy and test with the sample image. The DIY, we are going to run the Python notebook to identify sign language digits. Then we will use MIX large and run 10 epochs to train your model. Then deploy the trained model to a real-time endpoint. All right, let's go and start the let's start the lab. It's the same drill. S3, go to the bucket, copy the URI, go to SageMaker, go to the studio, open the studio, then open the Studio Classic or Jupyter Lab, then go to terminal, install unzip, copy the file from S3 and then unzip the file. Okay, then we are okay. I think we are going to change what? Click settings. I think they changed the theme a while ago as well, right? So now let's see settings. Oh, the first thing is the theme. They choose dark. Okay, I think our theme is already dark, so we should be good. Then let's open the TensorFlow practice and we'll pick T3 medium. Then we will go through whatever is in the notebook, so we don't have to scroll through here. Okay, Okay, I think we'll deploy it after this. I think where are we deploying it? Here we go. I think pretty much that's it. Endpoints, click refresh. Why are we going and refreshing? Results are cached. You might need to widen the window to see the status, and then you can see that's endpoint. I don't know why they are showing us that. AWS settings. Oh, they are showing us the job is actually a TensorFlow. That's what. Anyways, so it's still starting. So let's give it some time. I think it will at least take what, 10 minutes to start. I will be back once that starts. All right, the lab is ready. Let's open it up. Let's go to S3. Open the lab bucket. Let's download this for my research. Let's copy it. Let's go to SageMaker. Studio. Open it. Click on that. It's running. Open that. Okay, here we are. Let's repeat the drill. I mean, when they can do this much, I don't know why they can install unzip on this. Some of them came with unzip installed, some of them didn't. I think the lab that they uh, no, I mean they are starting this all on by their own. Like when we are spinning the lab, they are not already pre-made. So not sure why they cannot. Okay, let's copy that, unzip TensorFlow. Okay, we have plenty of images because we are training those, right? Oh, I think we have almost what, 10,000? I think that's what they said, right? C for 10,000 or 5,000. All right, let's keep it going. In the meantime, while that is happening, we can open our notebook, which is right here, and T3. Yes, that's what we are going to pick. So TensorFlow is one of many deep learning frameworks available to researchers and developers to enhance their applications with machine learning. AWS provides broad support for TensorFlow, enabling customers to develop and serve their own models across computer vision, natural language processing, speech translation, and more. You can get started with TensorFlow on AWS using SageMaker, a fully managed service that provides machine learning developers and data scientists with the ability to build, train, and deploy machine learning models quickly. You are tasked to create a machine learning model which is capable of identifying a cat or dog or frog that visits the city vegetable garden. You decided to use the TensorFlow framework to solve object identification problems. You are using the CIFAR 10 dataset as a sample dataset to investigate your approach. About the dataset, the CIFAR 10 dataset consists of 60,000 32 by 32 color images, as you can see here, in 10 classes with 6,000 images per class. Okay, makes sense. There are 50,000. I think we will still be okay. That is done. Wow. There are 50,000 training images and 10,000 test images. And the 10 categories are airplane, automobile, bird, cat, deer, dog, frog, horse, ship, truck. This lab is designed based on the AWS samples available in the following, and we already know this GitHub repo. Oh, this is samples. This is different than the SageMaker examples, but you can go here. Note to run the code cell, press Shift and we don't need to do that. update the SageMaker to the latest version and install the TensorFlow framework. Okay, let's click on it, run it, and then once we import the libraries, not import, install the libraries, we will import them. Validate if the TensorFlow is installed correctly. Okay, that's what we are doing here. All right. Once we do that, we import pretty much everything that is required. So matplotlib to, I guess, plot once we train the model, and then we use SageMaker TensorFlow, SageMaker execution role, and NumPy and etc. Okay, it is taking forever for that installation. That's fine. Once we do that, we set up logger, info logging, etc. Then we log info using TensorFlow version, SageMaker version, seed for reproducibility. Okay, so we set up seed. This is like Minecraft seed. If you want to reuse the same map or regenerate the same map, you assign a seed to it. So here the same thing. If you want to reproduce the same thing, seeding is important. So that is installed. So let's import this and let's see if the install, yes, it is imported or installed correctly. And let's import all of this. And okay, that is done. Now let's set up the log level. Then let's print the versions of both. Okay, hold on a minute. The TensorFlow version here it showed is, oh yeah, the same. Okay, never mind. Let's set that up. Okay, now let's create roles, sessions, and data locations. Let's, oh, do I still have it? The bucket name, let's see. I think I copied the entire URI, right? So I can get the bucket name from it. Prefix CV models, that's the file name, I guess, inside this one. First, we will train a convolutional neural network model to classify images from the CIFAR10 dataset. Image classification is the task of assigning a label to an image from a predefined set of categories. CIFAR10 is an established CV dataset used for object recognition. It is a subject of the 80 million tiny images dataset and consists of 60,000 color images containing 1 of 10 object classes with 6,000 images per class. The first step is to load the pre-shuffled dataset into our train and test objects. Luckily, Keras provides the CIFAR dataset for us to load using the load data method. All we have to do is import keras.dataset and then load the image. All right. Okay, this is loaded, I guess. But how do these? Okay, we are printing them here. Okay, my exact question. All right. So I think it might be, is it a bigger image? And okay, so what is this? X-train, Y-train test. Let's review subset of data. Okay, I guess this will show it for us. Oh, okay. So is it loading it like a big template, and on that template we are getting, hold on, X-train 50,000, I think, is that the size of it? And what is 3? No idea. Is it, no, is it 3? I don't think so. Let's see. Rescales the images by dividing the pixel. I think that's the pixel value, 32 by 32, but what is 3? Where we are dividing the pixels or what? What are we doing? One hot encoding is a process by which categorical variables are converted into numeric form. One hot encoding converts the 1 by n label vector to a label matrix of dimensions, where n is the number of sample images. So if we have 1000 images in our data set, the label vector will have the dimensions. After one hot encoding, the label matrix dimensions will be that. That's why when we define our network architecture in the next step, we will make the output softmax layer contain 10 nodes. where each node represents the probability of each class we have. Okay, then unique, length, wide train to categorical. Break the original train dataset further into train and validation datasets. Okay, we are splitting them into two sets. Create a local data slash directory to save the dataset. Okay, now let's make the directory. If it exists, that's fine. Save train validation test datasets to local data directories. How many did we divide them into? So 5002 remaining, that is train. First to 500, that is validation. Okay, let's run this. We are using NumPy. Copy train validation and test data sets from the local directory to S3 since SageMaker expects datasets to be in S3 for training. And then, okay, hold on a minute. Okay, let's run this first because we know that it is going to take some time. Okay, once that is done, using the S3 locations of the datasets we saved in the previous step, create pointers to these datasets using training input class from the SageMaker SDK. So trainer input, it's pointing to the S3 bucket. Distribution fully replicated. Content type, is it, what is it? NumPy. Validation input, training dataset again, same thing. We are just storing them into these variables. Test data input, same. Oh no, 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 no. Okay, that will fail. We have to run this and then that. My bad. Okay, I missed another step or what? Oh, they want us to give the bucket. Didn't they? How did they get the bucket here then? Does not exist. Oh, never mind. Okay, we ran here so far. Okay, that's fine. Where did we set the bucket? Somewhere we would have set the bucket, right? We did set it, right? Oh, we didn't run this? Awesome. Let's run that. And what is this using? Bucket and prefix. I guess we didn't use them anywhere here. That's why they all worked out. See what happens if you miss one step, and I'm not even checking this. Maybe you saw it. Let's run it. So it will copy to the bucket and with those prefixes. Okay, that is done. Now let's go ahead and create this. Oh, it's still not done. Now it is done. Okay, so we created that way, those variables. Now let's go ahead and we are preparing a what? A dictionary with the training input, val input, and all that. We will, did I run it? No. We will build a small CNN consisting of 3 convolutional layers and two dense layers. We will use the ReLU activation function for all the hidden layers. In the last dense layer, we will use a softmax activation function with 10 nodes to return an array of 10 probability scores. Interesting. So this is the model. Okay, seed. Okay, go through that. Okay, let's train that model. I think this code is available anyways on the GitHub that I showed you, so I don't have to show you all these files. You know where to get them from. That's it. It ran. What? Unbelievable. Oh, it didn't fit it now. Never mind. Okay, let's run that now. I was like, seriously? But yeah, it didn't run. Usually, all our previous projects had fit. This one didn't. Okay, once that is done, We are going to star and zip our trained model, and I think we are going to put it in our S3. So let it run. I don't know how long this is going to take. Too many images. I hope it will take some time. They didn't even mention it here. Maybe they mentioned it in that, but let's see. All right, it is done. The log shows training environment. You can see hyperparameters, input config directory, data etc. Environment variables. All right, we printed all that. Uploading generated training model. Okay, I think this is here. I think that's about it. Okay, it took about 700 seconds. Let's upload the trained model to S3 and let's copy it back to the S3. It just, I guess, prepared the, put that in the variable. Let's print the current time. Okay, this is again preparing the variable, and we are going to model define a TensorFlow model. Then what did we do here? Train. Okay, once you train the model, then you will define TensorFlow model. Okay, with this image. Okay, so far that's our model. Then we are defining as a TensorFlow model, and the TensorFlow URL. This is the ECR. From ECR we brought that image using the role, and output is that bucket. And now we are deploying the model to an endpoint. So we are taking our model. Hold on a minute. Let us get this straight. Image URI that, okay, this is the model. Okay, our output, we are taking the data, output model, output data. Is that it? Okay. Yep, that's it. And then defining a TensorFlow model, and then we are deploying that model here. Okay, this is going to take some time. And I think pretty much that's it. Once that is done, we are going to plot it and see. So let's wait for a few more minutes, I guess. Okay, so that is done. The model is not the model. We deployed the model, and let's do the testing. So we are importing all these awesome libraries, and then these are our labels, all the 10 different labels. And the image we are uploading looks like is a cat image. So let's see. Wow, even humans cannot identify that. And we are loading the image to array, then float as a number. We are then dividing it with that and reshaping it to that. I'm interested to see how data looks like. All right, so that's the data. Okay, it's missing so much, but that's okay. Payload, loading into that. Predictor predict. So this is where we ran it. Now let's numpy predictions 3. Is it from here? 0, 1, 2, 3. A cat. It figured it out. Awesome. And then it's predicting, it's getting that. Okay, I think that's about it. I think the only difference we saw is once we train the model, once we got it, we are actually deploying it as a tensor model. I think that is the difference. So let's go, let's finish the DIY fast. So let's open that. Then we'll use X large 10 epochs. Okay, so let's go. Okay, this time we are going to use a different notebook. So I'm not sure how that is going to work. So let me close all these. Yeah, I would like to leave that. And let's open this one. Let's go full screen. And let's click on this. What do they want? M5X large. Okay, let's do that. You are now asked to solve another problem based on computer vision. Your task is to identify sign language digits. You will again use TensorFlow frame to solve the sign identification problem. You will use the sign language digits dataset as a sample dataset. Sign language digits dataset distinguishes the sign language digits from 0 to 9. The following images show a sample of the dataset. This lab is designed based on the again another repo to run. Okay, if you want me to open that, I can do that. It's called multi-model input TensorFlow computer vision. Did they open the same one? Maybe not. Okay, so we are doing the same thing. We are installing all this and then we are printing the version. We are importing everything. We are logging them. We are again setting a seed for reproducibility. Okay, replace with the bucket name. Okay, where is it? Okay, here we go. I don't think I have the bucket name, do I? Oh, I still have it. Is it a separate bucket? Let me go and see. I don't want to overwrite or try to use the previous one because even they are in the CV models. Oh, okay, never mind. I think they are in. Let me see. Uh, okay, don't we have? It's the same. So why are we using the same one? Do we have another bucket? I don't think so. Okay, let me go back here. Okay, we are creating these. We are not accessing anything from there, so that should be fine. I think in here, if you see, we, oops, previously in this, we created this one and then out, etc. So that should be fine. And here we are going to do the same in a different. I think that should be fine. So let's see. Okay, it installed it. Let's import this to test if TensorFlow is installed properly or not. Okay, to it's installed properly. Let's import all of that and let's log this. Let's print those logs here. Let's set the seed up and then let's create these variables, bucket and prefix, and let's create these variables for the train path validation path. And from train path, what is this? I think in here, is it from here? Train path is for the data, sign language, train 0. I think we are trying to show it. They're showing it here. I don't know why I'm trying to even see that. Okay, that's what we are going to find what that means. Image shape is 100 by 100 3. What is that 3? I am not understanding what that 3 is. Batches of tensor image data with real-time data augmentation. The data will be looped over in batches. So I think that's what this is doing. Found 1712 images belonging to 10 classes. Train batches, which is this next shape. So I think it is getting, it's 100 maybe the largest. Visualize random sample of images from, okay, randomly. Okay, okay, sample images. Then we are copy local data to S3 for SageMaker because SageMaker only gets it from. All right, I don't know why they didn't make us do this in the terminal. I thought they said there are only 1700 maybe per class. Still, these are a lot. Okay, looks like it is done. Let's see the model that they created. Parse arguments. I think before understanding this, I think we need to understand the theoretical part of it, I guess. Define a new model, compile new model, load base model, and freeze. What is this? VG16, VG16. I think those are some algorithms, I guess. Okay, let's put it there and let's create this estimated param invalid syntax. Oh, okay. We are supposed to give the instance type. I think they have told us to use ml m5x large. M5x large, and I think epoch they told us to give is 10 epochs. Where is that? Okay, it is here, so let's give it 10. Let's run that. Okay, now the fit, it will take some time, so let me pause it. All right, we have that ran. The training model is ready. Now let's convert that. First of all, let's zip it and put it on S3. Okay, that is done. Now let's print the time. For some reason, let's bring in the TensorFlow image, and then let's define the our trained model as a TensorFlow model. And then what next? Let's deploy it. It's going to take a couple of minutes. Let's see, what are they asking? They are asking endpoint. I think that should be fine. We can get it from here. But if you remember, they showed us something like, if we go to jobs, training, is this from here? This is the previous one. If I click on that, I don't think it is this one, is it? No, I don't think it is here. We have to go to the SageMaker. Let me go there. I mean, in the meantime, it will run. That's fine. Inference, endpoints, the previous one. Yeah, and this one, but I'm just trying to see what did they want us to look at. Hmm. Yeah, we know that's the model name. Okay, anyways, so let's wait for this to be done. I think pretty much once this is done, we will copy its name. Oh, it's already here. Let's copy it. Let's paste it here. Once this is finished, all we have to do is hit that and DIY is done. Even though these projects, at least you will be watching, I think 40-45 my minute video, but for me, I have to wait a lot of time. At least each project it is taking almost 1.5 hours. Only, I know that in real time these models will be trained for hours and days, but I mean, this is just a lab. So yeah, makes sense. Let me come back. All right, it is now deployed. Let's look at it and let's test it. Let's import those, and we are going to use, I guess, this image, which is that. Okay, let's run this and let's see what it means, I guess. And now let's predict it. Predictor label is predictor label 2. What is that? I don't know what that 2 is. I think here they will print it. Let's see. 2 is 2. Okay, that is number 2. Is I don't know what that is. I assume that's what it means. All right, let's validate it. Let's get done with this. So in this one, we learned how to use TensorFlow model, not use TensorFlow model, how to deploy our model as a TensorFlow model. All right, so let's go and do the quiz. I think in the last quiz they didn't ask us any questions regarding why are they showing me this? They didn't ask me any questions regarding SageMaker. Thank you for the sample approach. We optimized both models and deployed them on SageMaker endpoints. I'm glad I could help. Yeah. So yeah, they didn't ask any questions for some reason. They are out of the questions, I guess, because we are doing last 12, 11 projects on SageMaker, and of course they are going to be out of questions. So I don't know if we are going to have any quiz questions on SageMaker or anything related to our project. Let's see one of the question. If I don't see any, then I will edit that part out, so you won't see any quiz. So let's see. The only way we can find out is actually zapping one of the drones. I don't know why this is okay. And it's feedback time. Go ahead, hit the like, comment, and share your views on this project. All right. This particular what do you call it? This particular season is not for everyone. It's only for, I guess, machine learning people. Either you already know machine learning concepts. Oh, okay, they are asking us. Okay, then the game is on. Which type of images are pre-installed with TensorFlow in AWS deep learning containers to deploy custom machine learning environments quickly? Docker. That's what we did. Again, pause it and answer. Don't copy my answer. Okay, that's not it. Okay, we have plenty of blue ones here. So let's go. Which AWS services help extract information from images and videos? Select three. I know recognition. I don't know. Look out for vision, panorama, select three, deep lens. This is something I don't know. Maybe if I watched those videos, I would have known. But this deep lens looks familiar. Look out for vision, Amazon lookout. Maybe this one. Let's see. Did you log me out? Don't tell me you logged me out of the game. Oh no. Okay, we are still here. What is this? Okay, if I click answer, okay, that is not the answer. Never mind, I'd have to find it that way. It's okay. So one right, one wrong. Let's see. Which type of API method is used to start the training of a TensorFlow model through the estimator? It's fit. 2 out of 2, 1, 2, 1, 2, 1. Okay, let's go and try to do two more questions. TensorFlow is a deep learning framework available only as AMI deployed on EC2 instance. False. 3, 1, and the final one. Let's go. A convolutional neural network is a class of neural network. What does a CNN specialize in classifying? Images, which is what we just did. 4 out of 1. So I think that's about it. Everyone, do post my score and your score in the comments. Let's see who won, and thank you very much for hanging out here. And I hope you enjoyed this video. Let me know in the comments. Have a great day. Peace out.